Alright, so in this video we're going to talk about undefined function. Now, when is a function undefined? Now, a rational function, which is a fraction, those functions are undefined, or that means it have no real value whenever the denominator is 0. That is because you cannot divide by 0. Please remember, you cannot divide by 0. So for example, a question might look like this. Find the value of x for which the function f of x equal to 4x plus 5 over x plus 2 is undefined. Now, to do a question like this, first thing we're going to do is set the denominator equal 0. So that x plus 2 in the denominator, equate it to 0. And then you solve for x. Solving for x, you're going to get x equal negative 2. So f of x is undefined when x equal to negative 2. That's because when x is negative 2, it won't have any y value. Alright? So here are two questions for you to try. Pause the video and attempt them. Given the functions f of x and g of x, find the value or values of x for which the functions are undefined. Pause and attempt. Alright, so starting with g of x. G of x is 2x plus 5 over x minus 4. So it is undefined when the denominator is 0. So we set x minus 4 to be 0. That will give us x equal 4. So the function is undefined when x is equal to 4. Now the next part, which is stating the value of x, for which f of x is undefined. So we set that denominator equal 0. X squared minus 1 equal to 0. This is where we have to remember difference of two squares. Remember difference of two square, a square minus b square. So in this case, we can write x minus 1 times x plus 1 equal to 0. That will give us x equal 1 or x equal to negative 1. So in this case, f of x is undefined when x is 1 or when x is negative 1. Nice. Alright, the next thing we want to talk about is using inverse functions to solve equations. So for any one-to-one function, this is valid. If f of x is equal to some number n, then x is equal to f inverse of n. So let's say x was 5 and n was 7. We're saying then if f of 5 is equal to 7, then f inverse of 7 is 5. Now if you don't believe it, let's do it with an example here. Example, let f of x equal 3x minus 7. Let x be 3. Then f of 3 is 3 times 3 minus 7, which is 2. So f of 3 is 2. Using the inverse rule, then that means that f inverse of 2 should be 3. Now if you don't believe it, we're going to check it. Look at it. Find the f inverse. To find f inverse, we interchange x and y. So x is 3y minus 7. Then we make back y the subject. So x plus 7 is 3y. And then we divide both sides by 3. Y is x plus 7 over 3. So f inverse of x is x plus 7 over 3. Now insert x as 2. F inverse of 2 is 2 plus 7 over 3, which is 9 over 3, which is 3. Look at that with the black arrow going across. That is showing you that f inverse of 2 is indeed equal to 3. Without even finding the inverse, we could have concluded f inverse of 2 is 3 just from the rule that we learned above. So if f of x is n, then x is f inverse of n. Wow! So here's an example to try. Given f of x is 4x plus 5 over x plus 2, find f inverse and hence solve the equation 4x plus 5 over x plus 2 equal to 3. So pause the video and attempt the question. Notice it said hence. Alright, let's attempt together. So part 1, it said we were supposed to find f inverse. So f of x is 4x plus 5 over x plus 2. So now all we're going to do is make y be f of x. So y is equal to 4x plus 5 over x plus 2. Then we need to now interchange x and y. So x is now 4y plus 5 over y plus 2. Then we cross multiply. We get x times y plus 2x is equal to 4y plus 5. Expand inside the bracket and then factor out y to get y is x minus 4 times 5x minus 2. And so when we divide both sides by x minus 4, y is 5 minus 2x over x minus 4. So f inverse of x is 5 minus 2x over x minus 4. So part A done and dusted. Next, it said hence solve the equation 4x plus 5 over x plus 2 equal 3. Now it said hence. Hence mean it wants us to use the rule that we looked at a while ago. So remember, now look at this, 4x plus 5 over x plus 2 equal 3. So what we're saying then is f of x equal 3. Using the rule, then we're saying that x is equal to f inverse of 3. Nice. So f inverse of 3 will be replace x with 3. 5 minus 2 times 3 over 3 minus 4. That works out to be 5 minus 6 over 3 minus 4, which works out to be negative 1 over negative 1, which is 1. So x equal 1. That is your answer. Using the inverse. So we're using the inverse to solve the equation. If you don't believe it, you can check the solution. Check it. When x is 1, 4 times 1 plus 5 is 9 over 1 plus 2, which is 3. 9 over 3 is 3. Notice that the equation is satisfied. And so therefore x is indeed 1. Wow! Notice we didn't cross multiply and solve it normally. What we do is just input x as 1. Nice. Alright, so here's a classwork to close out the video for you to pause and attempt. So f of x is 3x minus 4. Find f inverse and hence solve the equation 3x minus 4 to be 5. And find the value of x for which the function is undefined. Pause the video and attempt. Alright, so for the first part, to find f inverse, we know we interchange x and y. To have x is now 3y minus 4. That becomes x plus 4 equal to 3y. Divide both sides by 3. And so that gives us f inverse is x plus 4 over 3. Now, 3x minus 4 equal 5. That is literally saying f of x equal 5. Using the inverse law, hence, that is saying x equal f inverse of 5. So f inverse of 5 is going to be, replace the x with 5. 5 plus 4 over 3, which is 9 over 3, and so x equal 3. So the answer for that equation is x equal 3. I know we all know x is 3, but please do not bring over the 4 and say 3x equal 9, divide both sides by 3 and say x is 3. When it says hence, it means using the inverse. Alright, so we use the inverse to solve the equation. Now for part 2, we want the value of x for which the function is undefined. So all you're going to do is set the denominator equal to 0. So 2x minus 3 equals 0. So 2x is equal to 3. Then you divide both sides by 2. In that case, h of x is undefined when x is 3 over 2. And that's it. Nice. Alright, so that's it for today. Alright, I hope you all enjoyed this video. Make sure to keep on practicing. Alright, and stay tuned for more.